Right, this time we're looking at how to use a multimeter. A multimeter is an electrical device or device for measuring electrical things. And we're going to measure two things. First I'll give you an introduction to the multimeter, then we'll measure a voltage of a 9-volt battery. We already know it's 9 volts, but we're interested to see what the actual voltage is, and then I've got a couple of resistors we'll measure the resistance of. We're not going to look at current in this one because current has a couple of little tricks that we want to cover as well. So here's a multimeter. First of all, we've got various different types, but they'll always have 3 sockets. We're only interested in 2 of those sockets today. There's one here which says COM. On my screen on my iPad it's actually back to front, so hopefully it's not back to front on your screen. But that COM is where the black one goes, the negative. It's COM because it's common to all. It always goes in there, common reading. The red one, when we're measuring voltage and resistance and very small currents, you can see by the units on the bottom there, it says V, it's got the omega, and it's got MA, which is milliamps. So whenever you're reading those things, you plug the red one into that socket. Okay, and the probes are just your bits that you stick into the circuit or wherever you're measuring to take the measurement. So we have the on-off button, and we've got this range selector in the middle here, this dial which we spin around to wherever we want. There's a little mark here to indicate this is the one that it's pointing to, and we're going to measure the voltage of a 9-volt battery first. So we know it's 9 volts, so we can go to the voltage range for DC voltage, which has got that solid line on it. Yep, solid line, dotted line. There's an AC voltage just here, and it's got a little wiggly line underneath it to show it's alternating, for alternating voltage. So going to direct current for a cell battery. If I was doing alternating, it would be something out of the mains most likely. You have to think about it and adjust your range accordingly. If I didn't know the voltage, I'd start from the maximum voltage, which is 500 on this, and then I'd measure, and then go down to the next one, measure, go down to the next one, measure, go down to the next one. And if I got this reading on my multimeter, let's see if I can do this with one hand, there we go. So if it showed up that 1, let's try that again, there we go, shows up with that 1, that means that it's gone too low, the range is too low, and I need to step it back up 1, back onto the 20 volt range, which means 20 volt maximum. You don't have to multiply by anything. This is 8.84 volts, 8.82, 8.84. Here's an interesting thing. If your multimeter is flickering on that last decimal place, the last significant figure, the way to deal with that is to ignore it and go to the last non-flickering significant figure. So if it's flickering in the upper range, I'd round up. If it's flickering in the lower range, I'd round down. And you just go to the second to last significant figure. That's how you do it. Okay. So anyway, that's measuring voltage of a battery. Voltage of anything is easy because you just connect it in parallel to whatever it is in the circuit. In this case, we're just putting the probes onto the 2 terminals of the battery. With a digital multimeter, and you're measuring something simple like this, doesn't matter if it shows up negative on the screen. It just means you've put these around the wrong way. And let's bring that up so you can see. And it's just a comment on positive and negative. It doesn't actually tell you anything that you couldn't work out for yourself. It's obviously an 8.84 volts. Okay, now I'm going to measure resistance. I'm going to use the same strategy that we used for measuring. There's a fly buzzing around this early in the morning, this cold, I don't know. Anyway, resistance. We're going to measure the resistance using the same strategy. We'll start with the highest reading because we don't know what the resistance is. I actually do know, but we're just pretending for your sake that we don't. And I'm going to adjust this. So when I connect this, in fact there's a point on connection. If you're connecting a resistor like this to the 2 probes on the meter and you're holding it with your fingers, your body is in parallel with that reading. So your body's resistance is connected in parallel, and so that will affect the value of your resistance. So ideally, you'd put it down on a non-conductive surface like glass or wood, and even those things still have a bit of resistance, but not a significant amount. My body has a significant amount for some of the ranges of resistors we would use. In any case, ideally that's what you do. I'm not going to do that here now because I don't have the time to go away far. And the access to show you what I'm doing. So when I read that, we get this on the screen, which means it's too high a resistance. So I'll go down to the next scale, which is 200k. That means up to 200k. And I'll do a quick reading, and it shows 0.0 it just shows 0.4, which let's see if I can show you on that screen. 0.4, which is way too small. We need to get more accuracy, so we'll go down to the next range, which is the 20k range. Okay, can you see that on there? 20k range, just there. And when I take the reading, oh, there we go, it's 0.47. Okay, so it's still not accurate enough for my liking. Down to the 2k range, and that gives us 0.477. On the 2k range, 2000 ohms maximum, that's what the k means, this times 1000, that would be 0.477k. So whenever your range reading has a k or a milli, you know those power of 10 multipliers, you modify your final reading by adding that multiplier on it. Okay, so this one is in the 2k range, so 0.477k, which means it's 477 ohms, which is about what I expect for this. If I go down to the 200 ohm range, this is what happens. Okay, and that tells us that we're getting a nonsense reading, so the range is too small for this reading. So I'd go back up to the 2k range, and that's going to be my reading. Okay, I was going to show you another resistor, but the video is getting too long. I think you've got the idea for that. One other point is when you're measuring resistance, you can't measure it while it's in a circuit, because the circuit is in the same way that I'm holding it, and I'm in parallel with this resistor. When I'm holding it, that's going to affect the value of the resistance that you measure. Okay, so measure resistors out of a circuit, or measure them out of connection to other electrical things. So that's the first one on a multimeter. Next one we're going to have a look at current and maybe continuity as well, which is quite a useful one for electronics.